forces. What are these lines of forces? Where this term arises? As we have studied earlier about the electric field. Now, electric field is shown by these imaginary lines which are known as lines of forces or electric field lines. As you can see here, we have considered a charge q and the lines of forces directs outward with this arrow. Now, how to find the direction of the electric field? As you can see, we draw a tangent out here on this curved surface, and the tangent which touches the curved surface at that point gives the direction of the electric field. Now, as you can see here, tangent drawn at that particular point is the direction of the field at that point. Maybe in the next point we will be getting a different direction. Now, coming forward, you can see we have to study about the properties of the electric field lines. Now, before studying about the properties of electric field lines, as I have shown, a plus q charge, a minus q charge has been placed. You can see on the plus q charge, the electric field lines points outward, and the minus q charge, the electric field lines points inward, or it shows as if the lines moves away from the charge, and for the second case the lines comes inward. So this comes down. Here we come down to the properties of the electric field lines. Here I have shown a system of dipole. Why dipole? This system helps us to study about the properties in a very clear format. Stating the first property, right from this image, you can see lines of forces originates from positive charge and ends at negative charge. As you can see, all the lines of forces originates from the positive charge and ends at the negative charge. See, for all the lines, for different cases, there can be n number of lines. As I have shown only 7 lines, but it can be any n number of lines, and they are really huge number. Now, lines of forces never intersects. As you can see here, none of the lines of forces have intersected. Then lines of forces repel each other laterally. As you can see, as they're repelling each other laterally, as you can see laterally they're repelling each other, due to which they can never intersect, and they try to shrink longitudinally. What is shrinking longitudinally? As you can see here, these lines of forces are trying to shrink and come down close to each other. This is the longitudinal shrinking. By length, it is trying to get shorter. Now, the next point, lines of forces starts from outer surface of the charged body. Yes, it shows that all the lines of forces starts from the outer surface of the charged body. As you can see here, all the lines of forces have originated. Either it had started or it have ended, but all from the outer surface of the charged body. So, from this diagram, we can study all the properties of the lines of forces, and coming down, we are also going to study about a particular case, that is electric dipole, a system comprising of two oppositely charged bodies having same amount of charge, like as I have written. So before studying about the system of electric dipole, we are going to study about uniform electric field. So what is uniform electric field, or how can we create uniform electric field? First of all, as we have seen the earlier case of dipole, you can see that here the field has a diverging or converging nature. Here it has a diverging nature, but it has a converging nature out here. But in this case of uniform electric field, we are going to study and obtain a uniform field that is same throughout the space. So how it can be created? Here we have placed a positively charged plate and a negatively charged plate. So when a positive charge plate and negative charge plate is placed, the lines of forces originates within these plates, and these lines of forces are the electric field. Now slowly you can see the lines of forces goes on increasing, which also states the electric field between these plates are slowly increasing. As the number of lines of force increases, the strength of electric field increases. Means one by one the count is increasing and the strength of electric field is increasing. So here at the bottom of the screen a question arises. Try to answer this question. Friends. So now we are going to discuss about the electric dipole and its field. As previously we have already shown, what is a dipole system? Comprises of two equal and opposite charges placed with a small distance gap. Here it is 2L. So now we are going to measure dipole moment. P, small p with this vector stands for the dipole moment, which is the measure of electric dipole. Is a product of charge into the distance between the two charges. It's a vector quantity. Now, as you can see, we are going to calculate about the field of electric dipole, that is the intensity of electric field of dipole on its axis. You can see here that charge plus q and minus q has been placed, marked as point A, point B. They are placed with a distance of 2L, each half L. Now we are going to measure the field at a point P generated by this dipole system. The point P is placed at a distance r from point A, and the point P is at a distance r minus a from point B. So now if you follow down the notes, we'll find we obtain the equation for electric field for plus q charge, electric field for plus q charge at point P. Then we obtain the equation for electric field minus q charge at point P, and at last we obtain the total electric field at point P due to this dipole system. Seen the calculation? I wish you have. There is one more statement that has to be mentioned. The direction of dipole moment is from negative to positive end, that is from negative end to positive end. The dipole vector has been directed from negative end to positive end, which is obviously opposite to the direction of electric field, because electric field generates from positive end and ends at negative end, and the dipole system has a direction opposite to the direction of electric field. Now, after performing the mathematics of the total electric field, we come down to the result in a form of 2pr 4 pi epsilon naught 1 by r square minus l square, that is the total result of the electric field due to the dipole. Now let's come down to a special case. If the p point lies far away from the dipole, like the p point which was placed on the axis is now at a far distance away, then the r value will be very large, and due to which L square can be neglected, and hence the electric field value or the equation has been written in form of 2p 4 pi epsilon naught r cube. Please look into the calculations. I wish you will find the answer. So now we are going to obtain the intensity of electric field of a dipole system, but now this will be on its equatorial plane. As you can see here, the P point lies on its equatorial plane, and both plus q and minus q are placed at 2L distance apart. Now the line joining the P points from plus q and minus q are placed, and using Pythagoras theorem we obtain the distance as L square plus R square for both the cases. The electric field direction that has been extended along the line joining from plus q to P is marked as EA, and similarly EB for minus q. Now when we have to obtain the electric field, we require to divide both EA and EB into two components, that is the sine and cos component. For EA, we break it into two components, that is an horizontal component EA cos theta and a sine component or the perpendicular component EA sine theta. Similarly, we do this for EB, that is EB cos theta or EB sine theta. Now as you can see, both the EA and EB cos theta are along the same direction, hence we have to add these two components. And similarly, both EA sin theta and EB sin theta are oppositely directed, hence it should be EA sin theta minus EB sin theta. So if you follow down the notes, you will find that the magnitude of both EA and EB will be same, which is 1 by 4 pi epsilon naught q divided by r square plus L square. Irrespective of the directions, their magnitude will be same, which has been mentioned here also. The magnitude is same. Now if you follow on the equations, that is the total electric field will be present only along the x direction. There will be no y component, as it gets cancelled due to same in magnitude. Hence the total electric field that we obtain will be along x-axis EA cos theta plus EB cos theta, and if you look over into the calculation, you will obtain this result. And similarly, if the P point lies away from the dipole, then L square can be similarly neglected, and hence we are going to obtain the total electric field in the form of this. So in during the calculation, you will find there is an approximation considered for the cos theta, that is cos theta has been mentioned as L divided by root over of r square plus L square. This has been obtained right from this diagram. If you look into this diagram, this angle is the theta angle, and if you follow up this diagram, if this comes down to the theta, hence this is the base and this is the hypotenuse, and hence we obtain this form of equation.